Hello, everyone, and welcome to JavaScript Days. You're tuning into Creating Animations Efficiently with GSAP, hosted by GreenSock. My name is David Green. I am Marketing Manager at Sencha for Walla and Fusion Charts, and will be moderating today's webinar. I am pleased to introduce today's presenter, Zach Saucier, GreenSock. Before I hand the mic over to Zach to kick off the webinar, I'd like to take a moment to remind you that this webinar is being recorded and will be available to view on demand on the BrightTalk platform. Additionally, we will host a Q&A session at the end of the presentation. If at any time during the webinar you have a question, please submit it via the questions panel. Zach, you now have the floor.
Hey everyone, as David said, I'm Zach Saucier, and I work full-time for GreenSock and freelance creating web animations. I hope that you can see me all right. Sorry about the low frame rate on the screen share. I've linked my slides in the chat, so you can follow along there if you'd like while I'm presenting. Also, sorry for any background noise that you hear. I live in New York City, and there are a bunch of hospitals near me, so I can't do much about that. But the focus of this talk is the how of animation, not the what. In other words, it's focused on the developer ergonomics of animation. Even if you follow all the advice that I give in this talk, I don't make any promises that the end product will be great. Good execution is important, but good animation requires good ingredients and good execution. You can't just mix everything together and expect it to be great. With that being said, good animation tools and techniques make things a lot easier. And GSAP is the go-to library for web animators because it gives you full control over your animations, animates anything, fixes a lot of browser bugs, and allows you to focus on the animation itself. That's why over 10 million websites use GSAP, and over 75% of award-winning websites use GSAP, and why most major brands use it. For example, take this animation. It'll load for you. It's a long sequence of SVG animations, especially using morphing. And how many lines or if you made something like this using CSS animations, it would require well over 1,000 lines of keyframes. But how many lines do you think it takes to make something like this in GSAP? 500? 300? This entire complex sequence animation was made using less than 150 lines of JavaScript. That's crazy, right? GSAP makes animating a whole lot simpler. If you've never worked with GSAP before, here are some good resources to start from. The Getting Started article, the Common Mistakes article, and the Animating Efficiently article that's on CSS Tricks, which shares a lot of the same content as this talk. Going through these resources beforehand will save you a lot of time down the road. Before going into any specifics about tips for how to write your code more efficiently, I thought it would be good to cover some general workflow tips. These are extremely basic, but nonetheless very important. First, have a very good idea of what the end result should be before you start. There should always be some dialogue and clarification questions between designer and developer. By trying to think of all the edge cases, like how will this animation be displayed across different screen sizes, what will be shown to people with prefers reduced motion enabled, will the content be switched out dynamically or is it always going to be static, you can choose the right approach of animating and perhaps not have to refactor everything down the road. Second, MVPs are extremely helpful. If I'm creating a page that has several animations on it, I'll often create each piece in a standalone way and then combine it later. That way it's easier to wrap my head around what needs to happen, and each piece can be switched out or removed easily. Lastly, forking is almost always a great way to start an animation project. Whether it's an old project that you have lying around or an article from CodeDrops, starting with something that resembles your end goal will help you focus on what you really need to do. But now we can move into the meat of this talk, tips on animating efficiently. Let's start out focusing on what happens within tweens, which is a single animation, and within timelines, which is a sequence of animations. The first tip is to use relatives. What do I mean by that? I mean, use relative tweens, like .to and .from, use relative values, like plus equals and minus equals, and use relative units, like viewport width, viewport height, percents, and such. Let's break down what each of those mean, one by one. First, all animations go from one value to another. For example, in this case, we have a from to animation, which moves our box or boxes from an x position of 0 to an x position of 100 over the course of 1 second. To say that our box is already at a position of 0, which it is by default, this tween has a little bit of extra information in it. So you could write it a little bit more efficiently by using a .to tween, by saying GSAP.to and the same thing, but only passing in the second part of it. That's one way that you can animate more efficiently. But what if you wanted to animate from a value of 100 to whatever value it currently is? Well, in the same vein, you could switch out the .to for a .from, and then it'll go from a value of 100 to a value of whatever it is, in this case 0. But say that our box is at an x position of 50 pixels. How could we animate it an additional 50 pixels from wherever it is? We could use a from to, like we see in the first code section here, or we could use the relative operators that GSAP has. And so here we see the from to example, where it starts at an x position of 50 and goes to an x position of 100. But we can make this less hard-coded by using the plus equals operator. So here we see the box being selected and a to tween, and then using plus equals 50. So it'll start wherever it is and go 50 pixels to the right of that. This will help us write our animation code more efficiently by not having to be as explicit about all of our values. Similarly, GSAP also provides an x% and y% properties so that you can move an element relative to the width or height of an element. So in this case, it would move the box half of its width to the right. And GSAP also understands viewport units, so you can use this syntax of having quotes and then a value to move things relative to the entire viewport. You could even combine percentages or pixel values with viewport units to make a more complex tween using different units in the same tween. Another key to animating efficiently is to use timelines. For example, say we wanted to animate multiple properties of our box one after another. We could use regular tweens to do that by using a bunch of individual tweens like we have here, affecting it properties of it each time, and using the delay property to separate them out. But the more efficient way to do this would be to use a timeline. Here you can see multiple tweens being added to the same timeline. By default, these tweens will be added in sequence, one after another. And so we don't have to do GSAP.to each time or add a delay for each. They'll automatically sequence one after another. And so a keen observer might also notice that there's an additional parameter in these tweens that there isn't in the one above, and that is the last one. It is called the position parameter. The position parameter allows us to edit the start or end point of our tweens without taking them out of the sequence. So in this case, it would add the second and third tweens half of a second after the previous tween ends. If we wanted to, but we can write this code even more efficiently. GSAP provides a way of passing default values to our tweens in timelines. For example, we could take out the duration 1 that was in all 3 of our tweens and put it in the defaults, and it will be automatically passed to each tween. If we wanted to override that default, we just have to specify the property and value in the tween variables when we wanted to have a different value. But that's not all. GSAP can write this even more efficiently using a keyframes functionality if you're animating the same object time and time again. Rewriting this with keyframes functionality, you could write it like so, to where you only have a single tween and an array of variables to create individual tweens from. You'll notice that here we don't use the position parameter. We have to use delay if we want things to be separated. So that's it for tips inside of our tweens and timelines. Now for some tips outside of our tweens and timelines. The first is to use control methods. Control methods can be used on tweens or on timelines. They include play, pause, progress, seek, and others. They allow you to create animations once and reuse them, and they allow you to scrub through animations and have multiple states. They sound pretty powerful, right? They are, especially when creating interactive animations. Let's look at an example. So here we have a box, and we are animating it to the right when we click on the box. So if I click on the box, you'll see it move to the right. But if I click on it again, nothing happens. Well, why is this? This happens because a new tween is created every click. And since the tween is relative tween, after the first animation, the start value is the same as the end value. So here, the starting X value is 100, and the end value is 100, so it doesn't move anywhere during the animation. That's no good. What we should do instead is to create the animation beforehand, and then use control methods inside of our click event listener. So here, let's add an X digit of 0. We click it, it goes to 100, but when we click it again, it'll restart instead of doing an animation that doesn't visually move the element. So that's what we want. Oftentimes, we want to reuse the animations that we create with multiple elements on our page. There's a few different ways to set that up, and the best way depends on the effect that you're wanting. The first is to have one tween with multiple targets. I hinted at this already. GSAP staggers and functional values are a great way to do this. The second is to use loops, functions, and GSAP's effects. We'll look at both briefly. First, targeting multiple objects with one tween. GSAP allows you to pass in a selector string like this, and it will automatically use document.querySelectorAll to select all the elements matching that selector. It will then animate those elements at the same time. Similarly, GSAP lets you pass in an array of objects or elements if you'd like to use that instead. Once you've targeted them with your tween, then you can use GSAP staggers. A stagger it automatically creates an offset in between animations. So here, you can create a basic stagger by just passing in a number. That will be the duration of time between each target's start of the animation, in this case, a tenth of a second. But GSAP also lets you set up much more complex staggers with ease. For example, this code will stagger your elements from the given element in a 2D grid way. So I know that's a little abstract, so let's look at a demo that shows that being done. Here, a stagger is being created from the centermost element and going out towards the other elements in both the X and Y direction. By default, or in this demo, we have it coming from the center, but we can change it to go from the end element, or we could tell it to go from the edges towards the center, or we could even tell it to go in a random order. Or if we wanted to, we could pass in our particular index, and it would go from that too. So similarly, we could tell it to just do it on the x-axis, or do it just on the y-axis, or we could change the ease of the stagger so that the ones coming towards the beginning and end are more grouped. Or if we switch to this one, the ones towards the center go first, and then the ones towards the outside stagger a little bit later. So all of this is easily done using GSAP stagger functionality. Functional values are similarly very handy. Most properties in GSAP allow you to use a function as a value, and it will pass in the index, the target, and the array of all targets to each function. For example, this code allows you to animate every other of your targets in the opposite direction as the last one using a single tween. Functional values are also perfect for choosing values from an array of values, like this. So here we have a set of colors, and they're being selected based on the index. Again, this uses a single tween. Loops are also key to creating animations efficiently. For example, here's how you could set up a sequence of animations where several elements on a page are animated upon user interaction. So let's take a look at the demo of what this does really quick. Here you see 3 different sections, and when you hover over one section, it plays an animation. When you hover over another section, it plays a different animation, but they're both the same core animation, just applied to different elements. So if we take a step back and take a closer look at the code, here we're selecting the necessary elements and scoping them to the given element. And we're creating a timeline for each section, and this timeline will be unique to that section because we scoped it in the variables above. And then we're creating some event listeners for each element. And so here we have, again, the same animations, but we're not duplicating a code because we're using a for loop instead. That way we retain modularity, that way we don't have to duplicate our code, but we can still have individual animations that aren't all applied on the same time to all of those different elements. Similarly, functions can allow you to keep your animations more modular. You can even return timelines from functions and add those timelines to other timelines so that you have nested animations. By doing so, we retain modularity while still having a single timeline to control our animations. This is exactly what the Star Wars pin that we looked at earlier does. GSAP also has a feature called effects that helps when making reusable animations. So here, I won't go into all details of this, but here we're making a basic fade animation that you can then call as a regular tween, like here in line 11, or you could apply it to a timeline also. You can even pass in different variables like the duration so that you can use different animations but keep the same core effect, which is really handy when you're using the same animation across different parts of a website. GSAP's utility methods are yet another thing that help us to animate efficiently. Again, we don't have time to go into what all the details of the different utility methods do, but they include random, wrap, clamp, shuffle, map range, and a bunch of other commonly used functions that are especially handy with animation. So instead of having to write your own random function or copy one off of Stack Overflow, you can use GSAPs, and it's built in already and allows you to go seamlessly to do whatever you need to do. There are also helper functions specific to GSAP that can save you tons of time. I wish I had time to go through these because they're really cool, but they allow you to blend ease curves, create flip animations, which is an animation technique to move from one situation to another, to change the transform origin of SVG elements mid-animation without any jumps, and much, much more. And last, but certainly not least, GSAP has a ton of really, really useful plugins that can help you animate things on scroll, use motion path animations, do SVG morphs, and a whole lot more. We're going to take a look at some demos, and a lot of them will use some of these plugins, and so I'll try and point them out as we go. But I want to close this talk with a few inspirational demos that were created in an efficient way. So again, this is, it might be a little bit bad on the frame rate, so you might want to pull up my slides here because the very last slide has all of these demos linked. But I'll play the animation for you. So here we have an SVG animation created by Cassie Evans that has a bunch of little parts to it, but it is created in a very efficient way. As you can see, she created a function and created a timeline like we talked about to keep it modular. She's also using GSAP's motion path plugin to make the animation of some of the particles a little bit more easy. But she does a whole lot of different techniques that we talked about in this talk, including using keyframes animations. If I keep scrolling, this is all that same function, and then she has a different function for a different effect. So you can see that she's creating each individual piece of the animation in a modular way, but then combining it into one timeline later on. This demo is created by a user called Nish. When you click on a page, it will use this GUI morph transition to go between two pages content, which is really, really cool and pretty common these days. So you can see here, he is using a timeline, but he's using control methods within that timeline to control the state. So this is all the logic that's involved, is just checking to see if the timeline is reversed. And if it is, he plays it. If it's not reversed, he reverses it. So that way, you don't even have to to build that logic yourself. You just use GSAP's control methods to do it for you. This one's a little different. It's created by Tom Miller, and when you scroll down the page, it'll use this glitchy effect to transition between this arrow and the background image that he has. And this is literally all of the JavaScript that he has for this effect. It uses SVG filters to create the glitching, and uses GSAP's scroll trigger plugin to trigger when to fire this animation off. This animation is a bit different than the ones that we've looked at. It's created by a GSAP moderator, GreenSock moderator named Blake Bowen. He makes some really cool stuff, but it uses WebGL and Pixie.js in combination with GSAP to create this particle effect, where you can literally have hundreds of thousands of particles running at 60 FPS in your browser. It's crazy. But here he uses a function, again, to keep his animation more modular. He uses GSAP's timelines and repeats and defaults to keep his animation, to write his animation efficiently. And then he passes in the actual variables that are then passed to the shader, the WebGL shader, to run this on the GPU, which is what makes it so fast and able to animate so many things at once. So this demo is created by Luis Hubrex. I hope I'm pronouncing that last name correctly, but it's a demo where you can click on a checkbox and it will stagger from that checkbox to all the other checkboxes to create this neat wave pattern thing. And this is pretty much just GSAP's stagger functionality, as you can see here, applied to a grid of checkboxes. Like, he had to hardly write any code to do this, which is super cool. So that's the last of the demos that I really wanted to show today, but there are a ton of other demos. Here we're on GreenSock's CodePen collections page. We've been trying to improve this recently to have more showcases because people make cool things with GSAP all the time. We hope to just show those better. So if you're interested in a particular type of effect, like how to use GSAP's Draw SVG plugin, you go to the showcase or the how-to pins for that plugin, and those are all listed in the GSAP docs as well. So I hope that you've learned both how to animate more efficiently and been inspired to make your own animations in this talk. But thank you so much for listening. I'd be happy to take any questions in the remaining time that we have now.
Great, thank you so much for the presentation, Zach. As you mentioned, we do have time for questions now. If you're still with us and have a question, please go ahead and submit it via the questions panel at this time. As of right now, we do not have any questions from the audience. So in the meantime, Zach, I think it would be great if we could see a couple more demos, if you wouldn't mind.
Sure. And feel free to stop me as I'm going through this if you have questions. Going to, I don't know, let's look at this WebGL pin created by Zinnia. Again, another great developer who uses a lot of WebGL. Here, he creates a different WebGL animation every time you click, so it's dynamically generated. And he uses a lot of, he uses 3JS and some dynamic generation to create the different animations each time that you click. So he's setting up a framework for animating and then passing in different variables to create these different animations, which is really, really cool. I see that we have one question asking how mobile friendly are these provided functions. GSAP is mobile friendly, so all of the web really is mobile friendly by default. Even if you have a plain HTML page, it is technically responsive. What makes things responsive or unresponsive on mobile pages is creating things in a way that doesn't scale. So if you hard code a bunch of values, then your animation might not be responsive. But if you're using responsive units, like I was talking about in my talk, And if you use responsive sizing of your elements, then you can keep your animations pretty responsive, if not fully responsive, in terms of the screen size. If you're talking about performance-wise, there are definitely certain properties and certain techniques that are more performance-intensive than others. So, for example, if we go to the particles demo that Blake Bowen made, this, if you run it on your phone, might not have 60 frames per second with 50,000 particles, which we have here. But my guess is on most modern phones, this would run at 60 frames per second. That's because the actual core technology that's being used is the GPU, and all of the rendering is done on that GPU. But if you tried to do the same thing using HTML elements, you wouldn't get close to 50,000 elements being rendered and animated at the same time with DOM elements. It just doesn't work that way. So when you're approaching animation, you have to really consider, okay, in what context is this going to be used? And do I have the ability to use more performance-intensive things like SVG filters, for example, which are notoriously bad at being rendered in a performant way? Or do I need to stick to something like WebGL, which performs better, but might be a little bit harder to create what you need? And again, it's not like you can do everything that you can in WebGL with SVG. It's just, sometimes you can create the same effects using different technologies or techniques. So you need to keep that into consideration. I see.
Looks like we have some more. Oh,
yeah, go ahead,
sorry.
David.
I was just going to say, it looks like we have some more questions flowing in. So it looks like you're on top of the ball here. Go ahead.
So I see another question that says, I've used GSAP with React. Are there any best practices for setting up timelines and adding it to it from child components? GSAP and React play together great because GSAP plays with all frameworks that run JavaScript pretty well. The difficulty with React is so React is stateful, and it tries to keep everything very modularized, like in their component. So that's what makes animations across different components really difficult. Well, they're tricky, I should say, not difficult. It's not always intuitive how to pass references from a child component to a parent container, and then potentially to another element or container. And so that's really the difficult part. GSAP will animate any DOM elements or JavaScript objects that you give it, so it doesn't really care about things like that. But in terms of React, the very popular thing to do these days is to use hooks to manage state in React, and again, that's doable. But I personally have found it a little bit easier to use React classes to do animations. It just makes it a little bit more straightforward to keep track of things. But in terms of passing references from one component to another, I'm not a React expert. I don't use it in my day-to-day job, so I could point you to somebody who can give you a more thorough answer about that. And the GSAP forums have multiple posts where people are asking a very similar, if not the same question. So I encourage you to go there for additional information. But yeah, it is definitely doable. I just can't write to you offhand what that would be. And another question, can CSS animations work together with GSAP? Can we control CSS animations with GSAP? So I have studied the topic of CSS animations interacting with JavaScript a little bit more in depth. That concept so taking a step back, CSS animations are not really meant to be messed with. You can't really take a CSS animation and slow it down, for example, over time, like you can with the GSAP animation. Like GSAP has a control method called timescale, which does that exactly. It takes an existing animation and changes the rate at which it plays to play the animation at a different speed. CSS is not built that way. It does not really allow you to interact with the animation or change it dynamically or update the values and have it refresh very easily. You can kind of do that with CSS variables, and you can set CSS variables with GSAP and animate those CSS variables. So in that sense, you could, but changing the animations around themselves is not really too feasible. But again, it doesn't really make sense to do so either. If you're going to need that type of interaction, or you need it to be dynamic in that way, it's probably best to just create it in JavaScript, like with GSAP, for example, instead, because then you have that full control over your animations, and you can change them how you need to. So I hope that answers that question. You guys aren't too quick at asking questions. I was hoping for more. We can go back to some demos.
In the meantime, you have gotten some good feedback. People seem to like what you've said so far. So we'll keep this going for the time being. In case anyone else does have those questions, please go ahead and submit them via the questions panel. And yeah, Zach, go ahead with your demos in the meantime.
Sure. I'll pull up a couple different things to show. So here we have GSAP's Draw SVG plugin. The screen's a little short for it, but here a Chinese character, the character Ai, which means love, is being drawn. So GSAP's Draw SVG plugin is great for drawing out things like this. You can see a bunch of different examples in the CodePen collection for that. The Morph SVG plugin, again, is super helpful to morph between different shapes. So I'll pull up a couple here. We'll have this morphing between complex shapes with different number of points, which is not something that you can do with just JavaScript. The algorithm behind this is pretty complex, so I don't recommend writing it yourself. I recommend just using the Morph SVG plugin. But it easily animates between shapes of different number of points. With easing, with bouncing, or whatever you want to add to it. It does it seamlessly. So here we have a more practical use of Morph SVG, where you click on a UI element, and it does a nice little jiggle effect. I don't know if you can see that in the screen share. But it's slight, subtle animation that you can sprinkle across your website and enhance the visual design of your website. And so Scroll Trigger is one of the more recent plugins that GSAP or that GreenSock has come out with. It can do a bunch of different scroll-based effects. Like here we have a parallax effect that I don't know if this view will show it. I think it will. So if I scroll, no. So this demo doesn't seem to be wanting to render right now. But anyway, you can create parallax effects with it, or this is a demo using a WebGL2 paired with scrolling. So a user can actually take their scroll wheel and scroll through this tube, which is super cool. Again, this effect might not be applicable on every website, but I could see a use case for it for sure. But yeah, GSAP's scroll plugin is great. It allows you to track the velocity on scroll as well. So here we have images being rendered, and they'll be skewed on scroll. So the angle of the top and bottom, you can see, changes as the page is scrolled. But yeah, there's all sorts of different things that you can create with GSAP. If you can render something with HTML, with CSS, with SVG, with WebGL, whatever, if you can get that in a browser and JavaScript has access to it, then GSAP animates it. So I hope you guys, oh, one more question, it looks like. Oh, no questions. Just wanted to say thanks for your labor you're doing. Very grateful for receiving it. Thank you. We love the work that we do. We love helping people. If you ever have any questions, feel free to go to the GreenSock forums and ask us. So if you're watching this talk later and you wanted to ask a question, just hit us up in the forums. We have a very good response rate and short amount of time between when somebody asks and when it gets answered. So always happy to help. But thank you guys so much for tuning into this talk. I hope you learned something, and again, I hope you were inspired and want to create something for yourself. Thanks.
Awesome. Thank you so much for joining us today, Zach, and for the awesome presentation. We look forward to you potentially joining us in the future for more events like this. And to everybody that tuned in today, we really appreciate your time. I'm going to go ahead and link the URL to the next JS Days session below, so please keep an eye out for that. Also, please keep an eye out for the link to the slides. I know that we've had them available in the announcement section, but we'll be sure to make them available to you after the session as well. So keep an eye out for that, and we look forward to seeing you on the next presentation. Thank you, Zach. Thank you, everyone.
Thanks, David.